calculation that we do in all of these, and that's to construct a confidence interval. So as before, this is 11.3. We're going to calculate a confidence interval to estimate the difference between two population means. In symbols, mu1 minus mu2. So this is going to look very similar to what we've done in the earlier sections. Okay, so if the confidence interval it can take one of three shapes. Both the lower bound and the upper bound can be positive. Both the upper bound and the lower bound can be negative. Or you can have the lower bound being negative and the upper bound being positive. Three different possibilities. All right, so what the confidence interval says about this thing that we're trying to estimate, this difference between the two population proportions. All right, so we're always estimating mu1 minus mu2. And if we're estimating mu1 minus mu2 and it gives us this interval, it's saying that mu1 minus mu2, there's a very good chance that that difference is in this interval. And every number in this interval is a positive number. So it says that mu1 minus mu2 is greater than 0. That's how mathematically we write positive. Something is bigger than 0, it's positive. And if you add mu2 to both sides, you get mu1 is greater than mu2. And if we have mu0 equals mu1, mu0 is mu1 equals mu2, which is what we always have. And the alternative is going to be mu1 is not equal to, less than, or greater than mu2. So the confidence interval shows support for the alternative hypothesis, mu1 greater than mu2. If the confidence interval is all negative, both of these numbers are negative, -7, -2, something like that, then this is saying that we're trying to estimate mu1 minus mu2, and since every number in this interval is negative, we're saying mu1 minus mu2 is less than 0. Again, that's the mathematical way to say negative, less than 0. Anything less than 0 is going to be a negative number. Algebra, if we add mu2 to both sides of this inequality, we get mu1 less than mu2. And the only place that that hypothesis would appear is in the alternative as well. And then the third scenario would be one like this, where we have a negative number and then a positive number, and 0 is in that interval. So what we're saying here is that it could plausibly be the case that mu1 minus mu2 is equal to 0, since 0 is in there. Adding mu2 to both sides we get mu1 is equal to mu2. And the only place that one's going to fall is in our null hypothesis. So it's only this last case that gives us evidence to support the null. These other two cases, evidence to support the alternative. So I think this is like the third grid that I've done that looks a lot like this. So hopefully you're picking up on this. And there's one for each one of these sections. All right, let's do a problem that uses this information. Okay, so if you were going to use the lower bound and upper bound, and you were going to use a formula, this is exactly what the formula is. If we want to estimate the difference between two population means, it makes sense to calculate the difference of the sample means. So that's how we start off. And this whole piece is the margin of error. So we have mu1 minus mu2 minus the margin of error, and mu1, or not mu1, but x bar 1 minus x bar 2 plus the margin of error. And that's going to give us the lower bound and the upper bound. But instead of using this formula, we're going to use the two sample t. Well, it's not a test anymore, so two sample t interval. That's what we're going to use here. All right, so this is a confidence interval problem. It says construct and interpret a 90% confidence interval. So that's what this problem is about. Some couples choose to have children, others choose not to have children. Young children require a lot of time. And this time commitment cuts into a parent's leisure time. A sociologist wanted to estimate the difference in the amount of daily leisure time in hours of adults who do not have children under the age of 18 and adults who do have children under the age of 18. So here are two groups: no children with children. Take a sample, and we're going to get x1 bar, S1, and N1. Take a sample of those parents without children, calculate their average leisure time, standard deviation, sample size, and then compare these two sample means using our procedures from this section. And we're going to calculate a confidence interval, and we'll actually estimate the difference in leisure time. Okay, a random sample of 40 adults with no children. Okay, I can already see that I got these. Oh no, I've got no children here. 40. Okay, random sample of 40 adults with no children under the age of 18 results in a mean. All right, so the random sample results in a mean. So that is the sample mean. 5.62 hours. Very nice. Over 5.5 hours of leisure time. Standard deviation of 2.43 hours. And then we do a random sample, again, of 40 individuals. And these individuals do have children under the age of 18. And from that sample, we find a mean daily leisure time of 4.10. It does appear to be less. 4 hours versus about 5.5 hours. Standard deviation 1.82. All right, so we're going to construct a confidence interval for the mean difference. So mu1 minus mu2, we're going to estimate. And what we could do to estimate is just to subtract this number minus this number, and we would get 1.52 hours. So it appears that the difference is not zero. It appears that someone who does not have children has about 1.5 more hours of leisure time than those with children. All right, I think we've got everything that we need. And instead of using these messy formulas up here, I'm just going to go ahead and use the two sample t int. Right, so here's the two sample t test. That's not the one we want. I'm going to go all the way down to the two sample t int, option 0 here. All right, we do have the summary statistics here for the two groups. So I'm going to select stats and then input the 5.62, all the information about the no children group. And then we'll enter the information about the group that does have children. All right, C level. Okay, in our problem, they wanted a 90% confidence interval. So I'm going to change that. This one's also going to ask you pooled, yes or no. What you would find is if you selected yes there, the standard error term here would be much different than what it appears here. So again, we want that to be no. And then the only thing left to do would be to calculate. All right, so x1 bar is 5.62, s1 is 2.43, and n1 is 40. x2 bar, 410, s2 is 1.82, and n2 is 40. The C level is 0.90. Pooled equals no. All right, we're calculating a confidence interval here. So when we calculate, it's going to report back an interval. 0.72016 is the lower bound, and 2.3198 is the upper bound. Degrees of freedom, 72. So if you take 40 and 40 and add them together, 80, subtract 2, 88, 78. This is a ways off. But we're going to just use the, we're not going to use the degrees of freedom here. All right, there it reports back all the summary statistics. All right, there it is, confidence interval. If we were doing a hypothesis test, this would be positive, positive, and certainly we would have evidence to show that there is a difference. One is definitely greater than the other. But here we're going to interpret this as a confidence interval. So we're going to say we are 90% confident that. All right, this thing that we are estimating is not the number of leisure hours from any one group, but it's the number of, it's the difference in the number of leisure hours. And guess what this is? This is your sample mean. So 1.52 is going to be right in the middle. Then over on this side, you're going to have the 0.72, and over on this side, you're going to have the 2.32. You can actually calculate the margin of error there. All right, that the mean difference in leisure time hours between parents with and without children. All right. So all of that, you know, this from here to here, we're really just describing the mean that we're estimating here. And so you can say it in different words, but you want to get the word mean in there, and then you got to indicate that it's a difference. So it's a difference between these two groups. And then the final thing is the interval is between 0.72 hours and 2.32 hours. So you list the interval numbers and then give the appropriate unit.